Here's problem 20. It says, what is the perimeter of a triangle with the following vertices? 2, 5, 7, 5, 7, 17. You could plot these exactly, but it's not going to make any difference. And I'm going to do it like we normally would do it, even though I can see these are perfectly horizontal from one another. But I'm not going to worry about that at all. I'm simply going to make a picture. I'm just going to put 2, 5 here. Again, I am not concerned that these are not in the right spots. So here, I got some points, and it wants to know the perimeter of the triangle that's formed by those points. Well, to get the perimeter, I have to know this length plus this length plus this length. So I need the length. Let's start with this side. I need the length between these. That's just the distance. That's the distance formula. And remember, the distance formula is simply basically the Pythagorean theorem. The change in your x's squared, that'll give you the horizontal length, plus the change in your y's squared. Change in the y's is your vertical length. And it's just using the Pythagorean theorem. We've used this enough that we should be used to this by now. So for this guy, change in my x's, 2 to 7. That's a change of 5 squared. 5 to 17, change of 12 squared. That's going to give you a square root of 169 when you do it. That actually comes out to be a perfect 13. This side is a perfect 13. Now I made that happen. It's normally not going to. You're going to usually have to round this. But in this case it came out to a beautiful 13. Let's look at the difference here. Again, it's going to be the change in my x's squared. 7 to 7, there's no change there. 5 to 17, that's a change of 12 there. So change of 0 squared plus the change of 12 squared. So that's going to be a square root of 144. Square root of 140 comes out to be a perfect 12. I come to this side. 2 to 7, it's a change of 5 squared plus 5 to 5. Nothing squared. So it's going to be square root of 25. So this side's going to be a perfect 5. So you have 5, 12, and this was 13. 5, 12, and 13 adds up to a 30. The distance around it is 30 whatever units, feet, centimeters, meters. We don't know what it is. But this is how we do these problems. If it gives me the vertices, I just plot them wherever, doesn't really matter. And then I'm going to find the distance of the one, distance of the other, distance of the third, and then add them together to get the total perimeter.